Well, hi everyone. Let this come into focus here. I have this interesting question here. What's 0 to the power of 0? Well, let's look. 0 to the power of 0 is, there's an error, domain error. We can't have a base of 0 with an exponent. So what is 0 to the power of 0? Well, let's just kind of explore a little bit. We may not be able to find the exact answer because it's undefined, but I wonder what it would approach. Okay, and we're going to talk a little bit about one-sided limits. And let's go with a table. Notice the base and the exponent here are the same. So what if I did 2, and then, so let's just say this is x, and this is x to the power of x, the same base. So 2 to the second power, that's 4. 1 to the first power, that's 1. Let's do maybe 0.5. What's 0.5 to the power of 0.5? 0.5 to the power of 0.5. Okay, I'm looking at 0.7071. Well, what if we do 0.25? 0.25 to the power of 0.25. That is the exact same value. That might be something that be interesting to look at. Let's look at 0.1 to the power of 0.1. That's 0.7943. How about we go 0.05? Let's go half of that. 0.05 to the power of 0.05. Now I'm looking at 0.86. So notice how it was going down, but now it's starting to go up again as we get smaller on our x's here. 0.8609. Let me put 0.01 in. 0.01 to the power of 0.01. Alright, interesting. 0.9 still going up. 0.9550 if I round properly, if I'm going to stay consistent. What if we do 0.001? 0.001 to the power of 0.001. Now I'm looking, we might be seeing something here. 0.9931. What about 0.0001? 0.0001 to the power of 0.0001. And I'm looking at 0.9991. 1, 2, 3, 4, 1. 0.12341 to the power of 0.00001. 0.9999. Alright, I'm guessing this will be about what we're going to see the rest of the way. And he actually get close to 1. So the problem, rather than, since we can't do these 0 to 0, let's say as x approaches 0, from the positive side, the negative is a whole different can of worms, of x to the x. So that we're talking in direct substitution, be 0 to the 0, right? Would be 1. I think that would be an approximation. So that's what we're talking about. This is what we're talking about, one-sided limits. This is from the right side, the positive, the right side. So, if I were to do this example here, make sure I got the right thing here. I've got this function here, and I want to look at these two values. And I'm going to use a graph this time. Okay. So, let's take the absolute, that's in math, and I think num, absolute value of x divided by, and then I'm going to divide it by 4x. And I found out earlier that it is important that you have parentheses around this whole denominator for it to graph correctly, or to graph what you want it to graph. Okay, that's hard to see. Let me close in a little bit. X is fine here. Let me just, that looked pretty low. Let me go just -2 to +2 on the highest y value and the lowest y value. Reverse what I just said. Okay, interesting. Okay, now if I were to trace this, notice on the right side, as I approach 0 from this direction, as x gets smaller, y is always just going to be positive 0.25. Now, from this direction, if I approach from the negative side, from the left side, the negative just means from the left. As we get closer to 0 from the left, notice that this is always just negative 0.25. All right. Now, what would I like for you to do? Your assignment will be, make sure I'm in the right course here. I'd like to see what you did with these notes, so please include those. And I think for the most part we're remembering that now. That was a while in coming. But let's do 38 through 40, 38, 39, and 40. Let's do 44 through 47. And let's do 49 through 52. All right. God bless you guys. Take care. And just I hope everything is going so well for you. Bye-bye.